Welcome dear students. Now we are going to have science 1 practical experiment number 2. The aim of the experiment is to study the dependence of electric current I and the potential difference V across a resistor and determine its resistance and plot a graph of V against I. For this we require apparatus, and that apparatus is the complete set. Now I will show you the set. Now here this is the Ohm's law set, you can see it clearly, all the connections are already made. Okay. Now I will show you how to take readings. First we will see the voltmeter. Now see here voltmeter, if you see the voltmeter is here, the scale is divided into. Now here if you say that 10 divisions equal to 2, okay, then this is 2, 4, 6, 8, 10. So here 10 divisions equal to 2 means 1 division is equal to how much? Yes, it is 0.2. So here it is 0.2, 0.4, 0.6, 0.8, then 1, 1.2, 1.4, 1.6, 1.8, 2 and so on. So like this you have to take the readings from the voltmeter. Okay. Now let us come to the milliammeter. Again see on the milliammeter, you will see here 10 divisions are divided into 20. Means 10 divisions equal to 20. So what is the value of 1 division? Correct, 1 division is equal to 2. See here, it is 2, 4, 6, 8, 10, then 12, 14, 16, 18, 20 and so on. Okay. So like this you have to take the reading from milliammeter. So I hope clear to you, voltmeter 1 division equal to 0.2, and on milliammeter you are going to have 1 division equal to 2 units. Alright. Now I will show you one reading how to measure. Now here you will see that we are going to measure the unknown resistance. This is the unknown resistance, and then we are going to measure the value of this. For that we are going to have 4 cells here. See here, cell number 1, cell number 2, cell number 3, cell number 4. Now this wire is there, which when it is here connected means one cell is connected. If it is connected here, 2 cells are connected, here 3 cells are connected, 4 cells are connected, and accordingly you have to take the readings from the voltmeter and ammeter respectively. Okay. Now let us on it. Now I will show you one reading and how to measure and how to take the reading from the voltmeter as well as ammeter. Now observe it carefully. Now here if you see, what is that? Now here you will see that the reading is 0.2, 0.4, 0.6, 0.8 and 1, means this is 1 volt. Okay. So it is on 1 volt, and if you come here, then here you will see that it is 2, 4, 6, 8 and 10, means 5 division. So it is 10 milliampere. It is 1 volt and 10 milliampere. So if you change the cell, you will see here it is 2 volt or 3 volt. See here it is 3 volt approximately. Now it little bit fluctuation is there. So it is 3 volt and then 30 milliampere. Like this the reading will be there. Okay. I will give you the reading as well as the calculation of this part. So here only thing is that how to take the readings from voltmeter and milliammeter is very important. Okay. That thing I will explain into the calculation part.
See the observations. Least count of ammeter is 2 milliampere. I have shown you that 10 divisions equal to 20. So 1 division equal to 2 milliampere. Correct. So the least count of ammeter is 2 milliampere, and the least count of voltmeter is 0.2 volt, because we have seen 10 divisions equal to 2. So 1 division equal to 0.2. Okay. So this much you have to write, that is least count of ammeter is 2 milliampere, least count of voltmeter is 0.2. Okay. So 0 errors were not there, so let it be as it is. Now the readings. So we have taken the 3 readings. Now first reading is here the actual reading and the corrected reading. As I said, there is no error, so corrected reading will be blank. Okay. Here also it will remain blank. So now the ammeter reading is 10 milliampere and the voltmeter reading is 1 volt. This is the first cell. Alright. If you connect second cell, it is 20 milliampere, 2 volt. Then the third cell, 30 milliampere, 3 volt. Okay, so like this, these are the three readings, and now we are going to do the calculation, and all that calculation part you are going to write it here. Okay, I have purposely erased this one so that you can write your own and take the mean. How to take the mean, that I'll explain you. Okay, now let us do the calculation for the first reading and then second and third. Okay, now see here. So first reading is 1 volt, that is the voltmeter reading, and ammeter reading is 10 milliampere. Now convert this 10 milliampere into ampere, that is 10 into 10 to the power minus 3 ampere. Okay, so this conversion you have to do, otherwise you will not get the proper calculations. So 10 milliampere is equal to 10 into 10 to the power minus 3. Okay, you know Ohm's law, V is equal to IR. Now we want to find the unknown resistance, correct? That is R. So just modify the formula. R is equal to V upon I. Okay, so you got R is equal to V upon Y. Now you know the potential, that is V is equal to 1 volt. So substitute 1 volt here. Okay, and I is 10 into 10 to the power minus 3. So here what happened, if you take this 10 to the power minus 3 to the numerator, it is going to become 1000 divided by this 10 as it is. Okay, then 0 get cancelled. So what you are going to get, that is R equal to 100 ohm. Alright, so this is first calculation. I hope clear to you. I'll repeat again. It is V is equal to 1 and I is equal to 10 to the power minus 10 into 10 to the power minus 3. Take this 10 to the power minus 3 to the numerator, it will become 1000 upon 10. 0 get cancelled. What you are going to get is R is equal to 100 ohm. Now let's go to the second calculation. So here V is equal to 2 volt and I is equal to 20 milliampere. Again convert it into ampere, that is 10 into 10 to the power minus 3 ampere. Okay, Ohm's law. What is the Ohm's law? V is equal to IR. R is equal to V upon I. Now substitute. V is equal to how much? 2 volts here. And I is equal to 20 milliampere. That is 20 into 10 to the power minus 3. Okay. Again this 10 to the power minus 3 goes to the numerator. Then it will become 1000. Okay. Then 0 get cancelled. 2 get cancelled. Again you will get R is equal to 100 ohm. Clear? This is second calculation. So in the table you are going to write here 100 ohm, here also 100 ohm. Okay, and now the last calculation. Here V is equal to 3 volt, I is equal to 30 milliampere, that is 30 into 10 to the power minus 3 ampere. Again Ohm's law, V is equal to IR, R is equal to V upon I. Substitute 3 upon 30 into 10 to the power minus 3. Again this 10 to the power minus 3 when it goes to the numerator becomes 1000 divided by 30. So 0 get cancelled, 3 get cancelled, you will get 100 ohm. So third reading is also 100 ohm. So here in this table you are going to write 100 ohm. Here also you are going to write 100 ohm, 100 ohm, and then total will be how much? 300 ohm. Correct. So 300 divided by 3 is equal to how much? Yes, 100 ohm. So the mean reading is 100 ohm. That you are going to write in your journal. Alright. Now you have to plot the graph of V versus I. So here I have shown you, this is the graph is there in your journal. You have to plot like this. Take x-axis, y-axis. On x-axis take 2 cm is equal to 1. So it is 1, 2, 3 and that is V in volt and show the arrow. Alright. Now on the y-axis you have to take 2 cm is equal to 10. So 10, 20 and 30. If you are having the space you can write more also. So I, and that is in milliampere or milliampere. Now first reading is 1 volt 10 milliampere. So here first point 2 volt 20 milliampere, 3 volt 30 milliampere. Join it and you will see that the line will pass through the origin. So like this you have to complete the whole journal and write your inference also. So in inference you are having the electric current flowing through the circuit varies directly with potential. That is the first fill in the blank. Second, the value of unknown resistance is equal to 100 ohm. And lastly, the graph between V and I is straight line. Okay, so like this you have to complete the practical. I hope this practical is clear to you all. Thank you.